Greetings and salutations. Welcome back to part 3 of the piston assembly tutorial, and today we'll be showing you how to model the crankshaft. Part 4 will be along very shortly to show you the actual final assembly, but for now I'm Garth. This is welbot 3D prints. Let's get cranking. Alright, so picking up from where we left off last time, we've finished off the modelling of the head, and today we'll be modelling the crankshaft. So again, found this image on the same page as I found the other ones. I had to make a few little measurement adjustments though, because it's that distance there is where the end of the arm will sit, and given it's 45 with a 2mm extrusion from there, we need to close that up to make it 38 without the extrusions, so that'd make the entire width 42, and this is the diameter of the circle itself, which needs to be 66 instead of 64. But apart from that, all the other measurements should be reasonably accurate. Not going to worry so much about the bottom ones, because I'm basically going to start by making this end and then kind of working my way across, and then we'll just copy it to make the rest. Alright, so once again, since we're working with components for an assembly, first thing we'll do is create a new component, and this time we'll call it crankshaft, and then we'll just hide the head since we don't need that. And if we look at our drawing, we're going to create this little end bit, which is that little plate down the end there. So if we look at the side view here for it, you can see it has an outer diameter of 144 and a width of 15. So we'll start a sketch. I'll just do it in the front plane. It's C for circle. And then set diameter to 144. Stop sketch. Select the profile, press E for extrude, and drag that out. Just type in 15mm, and we want it to be a new body, so that's all good. Alright, now if we look at this sketch again, we've got a diameter for those holes of 109, and the hole itself has a diameter of 10. Okay, so we'll create a sketch. Since it's on the plane, we'll just do it there as well. Could have done it directly on the face, doesn't really matter. And what we'll do is hide the body for a minute just to make it easier. Turn on our construction, because we're going to use this circle as a reference for where to place our other circle, and I think it was 109. Yep. So set the diameter on that to 109, and then go back to our circle tool and just zoom in there. Doesn't seem to want to lock to that one, so it doesn't really want to lock to any of them. Not that it really matters. So turn off construction. No, have to select it first. Turn off construction, because this is going to be our actual hole diameter. And we could have used the hole tool, but given that we want to put these in a very specific spot, it's probably a bit easier to do it this way. So set the diameter to 10, and just hit escape. And what we'll do to make sure it is lined up correctly, select that point, and we want horizontal vertical with that, and then we can go, oh actually before we do that, oh actually no, we will do that. Stop the sketch, and then we can unhide our body, select our profile, go extrude. This time we just want to go all the way through, and we do want it to be a cut. So there's our first hole. Now if we look at the drawing, we've got 4, 5, 6, 7, 8 holes. So what we can do now is pattern. Now we want a circular pattern, and we want to do features, and our feature will be that last extrude in the timeline there, and the axis we can select the y-axis, and we do want it to go full, and quantity 8, oops, 78, 8, and compute option adjust, I guess that'll do. Alright, so there's our little initial plate with the holes. So next thing we want to do is we'll create the central kind of core that joins between the plates, and as we can see down here in drawing B, because that's where B points to, that has an outer diameter of 78 for that kind of little extrusion bit that sits around the outside of it, and an inner diameter of 64. So we'll go back and create a new sketch. We can do it on the front plane again, was that measurement? 78 and 64. So we get circle. Might as well do both on the same one. 78. 64. Alright, now we can stop sketch. And if we look here, the little extrusion thing is 2 millimeters. And it's very hard to tell if it's kind of chamfered back towards the surface or not. Kind of doesn't look like it in this one, but the lines there make it look like it is. Probably really doesn't matter, but we'll see how it looks. So we extrude. This time we want 2 millimeters, or -2 in this case, and we want it to be a join. Yes. Okay. And for the next one, that gap there, I'm just going to go off that one there, 38 mil, but that goes from the edge of that plate to the edge of that plate. So and as we can see here, it's got a distance of 38 between the two plates. So we extrude this one 8 mil. And join. And that's pretty much the first bit of that. Okay, now to create the extrusion on this side, we'll create another sketch. Just select that face, but to save us from having to draw another circle, you can use project include and project the outer circle, and hit OK, and as you can see, that's pulled that across to there for us. And the good thing about projected geometry in that sense, since we're not altering it or anything, if at a later stage we wanted to make it so that this was actually a little bit wider and we changed the dimension of that original sketch, it will automatically update that projected sketch to match it, which is quite fantastic. But since we do want it to be the same, we can just select the profile itself, hit extrude, and we want to go back in towards it. Just want to make that 2 mil, but we don't want it to be a new body, we want it to be a join. Oh, that went the wrong way. So we come back down here and say edit feature, and we'll say -2. That's more like it. So now we're ready to come and create the first of our little weighted plates. Okay, so for this bit we can just create a sketch straight onto this face, and we know the center point is the origin. So if we look at our diagram here, we can tell the center point of this circle is 44 mil up from the center point of the origin, and then we've got a 72 mil circle for the little extrusion on one side of the plate, and a 66 mil extrusion, 66 mil circle for the actual cylinder itself. So I think the best way to start would be to give ourselves a little construction line. It's probably going to be the easiest way. Just go straight up and set the dimension on that to 44. Was right, 44, yep. And then we'll create a 72 mil circle. So it does look as though that extrusion joins up with the top edge of the plate itself. So 72 mil circle, just C for circle. Drag that out. Just take that off construction and set the dimension . 72, and if we look at the diagram and kind of think about how this is going to be made, I'm actually making this from the back side of that, but I'm actually doing it upside down. We're going to flip that afterwards. I'm just going off this diagram here. So we'll leave the inner cylinder for the moment, and we can see that from the center point, or the origin in our case, there's an arc going around there with a radius of 80. And since it appears to be a circular arc, we'll just do a circle, drag it out, construction's on again, turn construction off, and set out dimension. Alright, so now to get the side lines, so these straight edges here, they've got a angle between them of 33 degrees. So probably the easiest way for us to do that is if we create ourselves a construction line, and I'm just going to make it really big because I don't actually know where it's going to have to be yet. Hit OK on that, turn off our construction, and now if we just do a couple of normal lines down that way so that they pass through the 80mm circle, and oops, zoom in a bit there so we can see. About there. Hit OK on that. And then if we grab our dimension tool, set that to 33 degrees. And yeah, because that point is coincident with that line, now when we go to set our tangency to this top circle, you'll see it just drags itself down along that line to make sure that we're keeping the lines in a vertical profile. Like if you didn't have that constrained to that vertical construction line, when you set the tangency, you might find that this point here would end up out here, and you'd actually end up with the lines going out that way or something. So now you can see it's nice and straight and perfectly tangent there. So we'll turn off our tangent constraint. Alright, well, to clean this up a bit, we can now trim off some of the excess stuff that we don't need. So hit T for trim. We can just go through and get rid of some of these curves that we're not going to need. Don't need these bottom bits either. It's alright, constraint warning. But I'll leave this inner circle here because we'll use that to create the outer rim of the extrusion on the other side of it. Just to save us drawing another circle. But for now, if we look at our profile, you can see we've got the shape of our little plate, if you want to call it that. I'm not really sure what they actually call it, to be honest. But we'll select all of that, hit E for extrude, and pull it out at 15mm. And we do want it to be a join. And there you have it. If we look at our sketch, these are, if you do the math, these plates actually work out to be like 15.5mm or something. Really not significant enough to worry about for the purposes of this video. But for the next thing that we want to do would be the inside circle, or the extrusion and the inside circle for the cylinder between the two. And as you can see, I've created it upside down, but again, doesn't really matter for this. So now we can create a sketch on that face, and again we will project just unhide the previous sketch for a second, project that circle through, say OK. I'll just go back to our front view, and the inner circle we want to be 66, see for circle again. Set the dimension of that one to 66. And we can stop sketch. And we can extrude that one. 2. What I might actually do is for this one, probably bring it out halfway and then mirror it, because as you can see it's got a matching plate on the other side. So normally that would extrude 42 mil. So rather than that, we'll pull that out, turn off our analysis plane, and pull that out to 21. We do want it to be a join. Features, and the features we want would be that one, that one, that one, that one, that one, and that one. Okay, so for the next bit, what we pretty much want to do is copy this entire section here over and then flip it around. And easiest way to probably do that is to actually split the body temporarily. And to do that, we need to make a construction plane. So we go offset plane, and we want it to copy from there because we've already got the extrusion on the other side. So we'll just select that face, and now if we go to modify split body, we can say that body, and splitting tool will be our construction plane, and we hit OK. So now you can see we've got two bodies up here. We've got that one and that one. So we can just hide our construction plane because we don't need that. And we go up to modify, move copy. We do want bodies, so we select our body. I might even select it there. Nice, right in the center point. And check that little create copy box. I'll just go to right view so we got a good reference. And yep, that's spot on. Only thing is, we also want to rotate it 180 degrees so that it's facing the other way. And as you'll see from our drawing, although the first one goes up in that one, the second pair goes down, and then the next one goes down, and the last one goes up. So we hit OK on that, and we'll actually repeat that. So go move, copy, create copy, back to our right view, drag that across, except this time we don't want to do the rotation. And one more time for good luck. Move copy, that can be a body, central, good. So go, oops, enable the copy and drag it across. Except this time, again, we want to do our rotation. Just type in 180 and OK. And there you can see we've got our nice little crankshaft. So now what we need to do is actually join those bodies back together, which is very easy to do if I can remember where it is. Combine, there we go. So target body, we'll just make it the first bit, and then the tool bodies will just be all of these. Oh, looks like we've got another duplicate there. Maybe it's just a display anomaly. We don't want to make it a new component. Just hide those. So this is going to be our main crankshaft body now. That's all one piece. The only other bit that is missing is the two extrusions at the end, but you'll notice that because we just did our copy, we've also got that little rim around there which we don't want. Now you probably find that I can't actually delete that. I don't know why. For some reason Fusion just seems to have issues with ends of things like that when I've done copies in the past. Yeah, as you can see here, it's got an error. If we click on it, it'll no doubt be extremely vague. The operation could not heal the edited region of the model. So helpful. So in that case, what we'll want to do is actually delete one further. And of course it selects everything again. So we just hold down Control, drag around that to deselect. And deselect, oops, deselect that face. And now it'll delete. Honestly got no idea why it does that, but it does. So if we come back to our drawing, we've still got our extrusion on that side. Now we just need the little 64mm one, and we need to drag it out 38. I know that 42 is under there, but that belongs to the red circle, so I want to drag it out 38 if we're going to be accurate. So we'll create sketch, and we'll just grab our other sketch. There we go. So we come down and project, and we just want to project that inner line. Okay. Stop sketch. Now we just select the inside profile, and it'll actually be 36 because it's already got the 2mm extrusion there. So E for extrude, pull that out, and 36. Okay. And got a 32mm diameter on the inner one. Doesn't have a length on it, but we'll just drag it out whatever length we see fit, but we'll create a new sketch just on that end one since we don't have a circle of that size already, and set it to the origin, drag it out, use our dimension tool, and we want it to be 32. Stop sketch, E for extrude, and just drag it out yay far, that'll do. And there you have it. Alright, well there you have it. That's how to model the crankshaft. And yeah, as I said in the intro, I'll be back shortly with part 4 to show you the actual assembly and sort of animating it, as it were. And yeah, if you've got any questions or comments, feel free to leave them below. And like, subscribe, all that kind of jazz. And if you want to support what I do, there's links in the description where you can donate. That'd be absolutely wonderful. And yeah, until next time, have a good one. Catch you then.